Hello everyone, good afternoon and welcome to today's webinar on AI for construction progress reporting. I am Abhishek Hiramat. I am associated with Desapex as Digital Design Manager. Today I'll be speaking how AI is transforming the construction industry and how AI is used for construction progress reporting. I am looking forward to share my thoughts on this exciting subject and hear your views on the same. So let's get started. Let me walk you through the agenda for today's webinar. We will discuss about current market scenario of AI, some applications of AI in construction industry. We will discuss what is construction progress reporting, what are the challenges faced while reporting construction progress, how AI can be used in progress reporting, and we will have a small case study and we'll be concluding the webinar. Before we jump into topic, we request the participant to take next 10 seconds to let us know about their professional background. So poll 2. Have you heard about how artificial intelligence is being used in construction industry? Please use the poll option to poll it. It will help us to understand the audience about the understanding of artificial intelligence. Thank you. So let's start with the first topic, current market scenario. The construction sector creates jobs and helps many nations economically flourish, with the market estimated to be worth more than $10 trillion globally. The construction sector is one of the largest in scale. In spite of being largest in size, construction sector has historically lagged behind due to lower adoption of new technologies when compared to other sectors like manufacturing or healthcare. However, the construction sector has made a great progress recently in integrating new technology such as building information modeling, artificial intelligence, which has the potential to completely change how we design, construct, and manage the infrastructure and buildings. According to the report by Markets and Markets, AI in construction sector is expected to grow from 1.2 billion in 2020 to 5.2 billion by 2025 at compound aggregate growth rate of 34.8% during the forecasted period. This is the current status of AI in construction sector. So now moving on to applications of AI in construction sector. First is structural health monitoring. AI can be used to detect flaws in structure such as buildings and bridges. The flaws can be detected and identified by collecting image of the structure and analyzing it with the computer vision algorithm. Such structural analysis can help to ensure that structure is safe and does not pose danger to people or property in the area. So these are some examples such as crack detection, identifying missing bolt or alignment in steel structure. Six, workplace hazard detection. So AI-powered computer vision solution has been developed to track, predict, and prevent workplace accidents. A computer construction company has implemented a AI-based system that uses cameras to detect potential workplace such such as workers are not wearing safety gear or workers standing too close edge of the building. The system uses computer vision and machine learning algorithm to analyze video footage from the camera in real time and sends alerts to supervisors and workers if any hazards are detected. The system has helped to improve safety on the construction site and reduce number of accidents. Quality control. AI can be used to automate material quality control. It can be used to ensure that construction process is accurate as possible by using camera to detect identify defects in the material. Example like detecting identifying material flaws, checking for dimension of the material can be examples of quality control in AI. Asset management and maintenance. Next is asset management and maintenance. AI can be used to monitor the condition of construction asset. This enables asset management by allowing managers to keep track which asset requires repair or replacement. It can help in maintenance by alerting workers when asset is being wear down or needs repair or replaced. AI vision helps in improving asset lifetime, reduce waste and shortens the delays. Next is material management. AI is used in variety of ways of material management. The automatic recognition and classification of building material in image or video stream is a popular application. This can be used for inventory management, material tracking, and other purposes. Another application is to predict amount of material required for a project. Understanding the shape and size of an object in the image or a video allows to be more accurate estimate of the amount required. This can help to avoid ordering too much or too little, as well as optimizing the logistic to save time and money. Next is construction progress monitoring. We will discuss about construction progress monitoring on later slides. So at Desapex, we strive to support the build environment addressing these challenges with technology and implementation. Desapex is a digital engineering firm committed to integration of digital technology in AEC industry. It provides a comprehensive digital solution for entire building life cycle from design to renovation stage. Desapex mission is to enable digital adoption and integration of technology for target value design, and vision is to have a sustainable built environment. We have headquartered in Bangalore and have our offices in three major cities in India: Hubli, Chennai, and Hyderabad. We serve customers all over the world, and we also situated in Sweden, where our team helps European clients to digitalize their property. Our team consists of passionate engineers coming from various backgrounds such as civil engineering, architectural, MEP, construction management, facility management, and also from software development. We want to help the overall business ecosystem by providing solution. Our organization is the world's first and only organization in India to receive the prestigious ISO 19650 KITEMAR certification for BIM design and construction. 19650 is a global standard for BIM framework where five of our projects were audited and we got this certification back in 2019 and recently renewed as well. It's a matter of pride for us to offer and the assurance to our client on quality of project delivery. We have experience in various customer segments such as hotel restaurants, corporate real estate, residential, airport, data centers, rail and metro, infrastructure, and etc. Our wide range of services to our client, we are segregated into three main verticals: digital design management, digital project management, digital asset management. Design management Since adoption of BIM is increasing among the architects and engineers, there is a still gap in both terms of capacity and capabilities. That must be bridged with a creating a digital 3D model to perform the various analysis. Our under TDM, we help designer owners to transform the traditional projects into BIM framework, and BIM models developed across are used in for visualization, clash detection, coordination, and later their models are taken for 4D and 5D simulation. Digital asset management is concerned with assisting building owner in effective managing their built environment. Here we use laser scanners to create a BIM model of existing facility. These BIM models are enriched with data to create a digital twin. Then the dynamic data from IoT, BMS and other sources flow into digital twin. This will help the owner to use it for energy management, maintenance management and asset management. This can really transform the way you manage the buildings. We are partnered with Finnish company called Granland as a decades of experience in consulting and implementing CMMS cloud platform called Granland Manager. This basically allows the smooth integration of BIM models and physical object in the building. Digital project management is a unique service we provide to streamlining the project delivery using BIM framework. Here, we work with the owners to review the current process and identifying the areas of improvement and add value using digital tools and processes. We work with the customer, define a project documentation framework as per ISO 19650. Then, virtual design and constructed models are taken up for 4D simulations. AR and VR are used to make a design decisions. During construction, we use AR and radar scanners for construction progress reporting. This helps the owners to keep their project status in check and meet the desired quality and timeline. After construction, we assist owner by helping them with the accurate as-built model updates and using radar scanners. Handover documents are embedded in BIM model and to streamline the operation pace. We have in-house traditional scanners like Leica and Trimble and dedicated field team for surveying and data capture. And back in office, we have a team to process and register the point cloud data. And from there, the technical team of architects and mechanical engineers developed the as-built model from the point cloud, which can be used for as-built and to asset management. So whether you have a building already built or having one coming up, Desapex can add value to your investment. So on-site construction management probably most critical aspect of CapEx project. We aim to provide the strategical planning, the progress monitoring. So what is construction progress reporting? The progress reporting is in construction refers to ongoing measurement and tracking of the progress of construction project. This include tracking of completion of specific tasks, reporting the status of the material and equipment, measuring the progress of work against the project schedule. The progress reporting helps to managers to identify any potential issue or a delay early on and allow them to take a corrective action to keep the project on track. It also helps in ensure that projects stays within the budget and completed on time. How is conventional progress reporting report carried out? So traditional construction progress reporting typically involves site inspection and observation by project manager or other team member. This typically document the progress of work by taking photographs, creating sketches, and making notes about the status of task and material. This information is used to update the project schedule, identify any potential issue or a delay, and track the overall progress of the project. What are the challenges faced during capturing by using traditional progress reporting. Inaccuracy. Inspection observation can prone to human error. Next is time consuming. Site visits, document control, and other tasks associated with traditional progress reporting can be a time consuming task. Limited data. The traditional method of progress reporting often rely on visual inspection and observation, which can result in limited data and lack of detailed information. Limited collaboration. The traditional progress reporting method can make it difficult for team members to collaborate and share information in real time. Dependency of manual data collection. Traditional methods rely heavily on manual data collection, which is results in lack of consistency and accuracy in the data. So these are the difficulties we encountered on site when it comes to construction progress reporting and tracking. Due to lack of systematic way of recording and presenting the progress information, about 70% of time in review meeting is spent in communicating the problem, rather than spending time to evaluate the problem and brainstorm the solution. Construction projects are planned and managed by diverse team known as project stakeholders, who are often geographically distributed. So AI plays a very important role to bridging the gap between project stakeholders to remote collaboration. AI-based construction progress reporting. So AI-based construction progress reporting is a newer approach that uses artificial intelligence, machine learning technique to track the progress of construction project. This approach can overcome many limitations of traditional construction progress reporting method by providing more accurate, detailed, up-to-date information about the project. So AI-based construction progress reporting workflow starts with data collection, information extraction, progress visualization. Data collection. How data is collected? Data is collected by using, sorry, can be data collected using photography. In 360-degree cameras are well-known devices for data capture. Construction manager or team typically capture more than 500 images each day with a variety of handheld or self cameras. And these unstructured daily site photo logs are used to extract information which is compared against the planned date. Instead, using 360 camera can be used for structure and order photo logs for progress reporting. Drones are quick and cost-effective methods of collecting data in area often accessible to ground or manned vehicles. Drones can be operated manually or provided with a pre-flight route, allowing a certain level of automation for collecting data. LiDAR scanners. LiDAR scanners are effective instrument for construction progress reporting using since they can record extremely detailed 3D point cloud of worksite. The scanner, like working principle of is it like scanner sends the laser beam that bounce off the things in surrounding, then measure how much time does it take the laser beam to return to the scanner. This data is visualized to generate detailed 3D point cloud of the surrounding. The point cloud gives you sufficient information of the site. Information extraction. How is information extracted after collecting this data? Computer vision has a potential to transform the progress reporting in construction. With the construction vision, image videos are captured on construction site can be analyzed automatically to detect, track the progress of various construction sites. So, for example, a leading construction company used a computer vision technology to monitor the progress of hospital construction project. What did the company do is that company installed cameras equipped with time-lapse photography to capture the image of construction site at regular intervals. These images then were processed using computer vision algorithm, which used object detection and image segmentation technique to identify specific object on construction site, such as walls, floors, and ceiling. By analyzing the movement and change in the position of this object over the time, the algorithm were able to detect the progress of construction activity. The output of the image analysis was a time series data set to capture the progress of each construction activity over time. The data was visualized using graphs and charts to provide a real-time report to show the progress of the project. The computer vision system also used for monitoring safety of the construction site. The algorithm used to detect object detection technique was to identify worker to track their movements as well. They were able to detect when workers were not wearing required safety equipment, such as hats or high visibility vests, and alerting to the manager in real time. Next is machine learning. Machine learning algorithms can be used to analyze data from the construction site and make prediction about future progress, identifying potential issue, improving overall construction efficiency. Here, one of the construction management firm used predictive analytics to identify potential project delay and cost overrun before they occur. Company predictive analytic tools called construction intelligence analyze the project data from variety of sources, including project schedules, labor productivity, material delivery, and weather forecast. The tool uses machine learning algorithm to analyze this data, identify the patterns, and the trend that can be used to predict potential delay or cost overrun. By analyzing this data, construction intelligence can provide the construction manager with insights into the status of the project and identifying potential risks and opportunities for improvement. The use of predictive analytics in construction reporting can help the companies to identify potential problems early on to take a corrective action and prevent delays on cost overrun. By analyzing data in real time, construction manager can make informed decision about the proactive measure to ensure the project stays on track and within the budget. This can help to improve overall efficiency and effectiveness of the construction project and ultimately lead to better project outcome. Next is deep learning. It's a subset of machine learning that involves training neural networks on large set of data to perform tasks such as image, speech recognitions, natural language processing, and prediction. Next is progress visualization. Once you have collected the data, you have extracted the information. How do you visualize the data? To visualize data, our virtual and augmented reality can be used. Analytical dashboards, 360-degree dashboards can be used for progress visualization. So, virtual and augmented reality. AR technology can be used to create a 3D model of construction site and that are overlaid on the real world, allowing project managers to see how much progress has been made where the construction is happening. AR technology used to create a digital models of construction site. These models can be viewed from different angles in real time. Virtual reality. So progress report data can be integrated into virtual environment, allowing stakeholder to visualize the construction site in more impressive way. This can be particularly useful for identifying potential issues and communicating progress for stakeholder who may not able to visit the construction site in person. Next is analytical dashboard. So progress reporting can be visualized on dashboard where different metrics such as computation of work, resource utilization, safety incidents can be tracked in real time. This can provide project manager a comprehensive way of the project, allowing them to quickly identify issue to take corrective action. In this image, you can see The ducts in the green are installed and the remaining ducts are not installed. This will be give a comprehensive way of how much of work is completed in one flow. And this visual inspection can be used for different trade as well. So completion of pipes or completion of electrical works. This give a brief idea what are the works are completed using the visual dashboards. In below we have dashboards where the whatever the plan date was and how much work when uh, actual work started, so the delays and everything can be visualized from the below one part. How analytical dashboard helps it helps in monitoring progress. Visualize the correct status of a project, including completed, upcoming milestones, and any delays. Track budget. Track actual cost against the budget. Identifying any discrepancy. Make an informed decision. Stay within the budget. It helps in improving communication. A shared project data with stakeholder, enabling the improved collaboration and decision making. Enhance productivity, identify bottlenecks, optimizing the resources, and improve the productivity by identifying area that requires attention. Next is 360 degree dashboard. So this also is a panoramic photo, can be valued tool for the construction progress reporting. They provide a detailed view of construction site that can be used to document progress of the project over time. By taking 360-degree photos and regular intervals such as daily or weekly, it is possible to track the progress of object and identify any area that may lacking behind the schedule. 360 photos can be used to create a virtual walkthrough of a construction site, allowing the stakeholders to visualize construction site in impressive way. This can particularly useful for identifying potential issues and communicating the progress for the stakeholders. Here is a dashboard where 360-degree photos is compared with the point cloud. And if you see, here is the floor plan of the plant room where these yellow points are represents the camera views, and we can go to this particular view and can visualize the what amount of work has been completed in that particular place space. And you can have a 360-degree photo of last week as well by just changing the date, and can visualize, you can compare with the present date data. Here is a small video where BIM model can be compared with the 360-degree photo. In this video, you can see that on the left side you have a 360-degree photo, and right hand side you have a BIM 3D model. This is exactly as you can see. You can see the as built model progress versus as planned model. If you want to visualize like what equipment can be come into this picture, and you can use the BIM model to use it to visualize that part. So 360-degree dashboard can be a very effective tool for progress reporting. So how does construction progress reporting help in 5D? Construction reporting using AI can aid in 5D by giving accurate and real-time data on status of work, such as quality of work accomplished, resources used, and time required to complete the task. It helps in accurate measurement. A AI-based system can properly measure the construction work progress, allowing for more accurate billing for finished work. It can help in real-time tracking. AI-based solution can assist the guarantee that work is done on time and within the budget by enabling the real-time tracking of work progress. This can help the decrease in billing disputes. Improve the transparency. Intelligence-based technology can provide a better insight into construction progress. This and can assist the guarantee that the invoicing is current and fair for both parties, for both contractors and the owners. I would like to share a few insights of one of the recent projects involving construction progress reporting. The problem said the client was coming up the internal road project with underground utilities. Design team were mainly working on 2D drawings. So here the client wanted us to develop BIM model, implement 4D simulation. They wanted to track project with reality capture and visualize the progress with AR and VR. So here the scope of our work to provide BIM model development and construction progress reporting using reality capture and visualization using AR and VR. So we came up with the solution during design phase of the project. We implemented ISO 19650 BIM framework and created a BIM model from 2D drawings and resolving the potential clashes and breaking the model as per the master schedule for 4D simulation. During construction phase of a project, we use laser scans to scan the site for as-built model and reflect the progress in BIM model. As you see in the screen, the planned work of 14 July to complete roughly 460 meters of stormwater drain, that is PVC trapped sidewalls and top slabs. But when the field was scanned and compared with actual, it brought to client notice that only 60 meters of overall work, 200 meter of raft works, and 90% of sidewalls were completed. And I would like to show some model versus on-site comparison which was performed using augmented reality to validate design model field construction. You can clearly see that catch basin, which was supposed to be here, has actually casted few inches to the left, causing connection and service coordination issue. We were very glad to say that client was able to identify this deviation before the service were installed on the field. Without this, there would be significant amount of rework on the site. You can see the images on the screen. You find the multiple instances how construction progress monitoring and reporting helped the client to reduce site rework. This is the entire project design model augmented on real environment for planning and execution cases. This is right here in Bangalore. We are very proud to say that client was satisfied with the tools and technology implemented during the support to support their project. So, coming to the future of AI for construction. So based on the current research and industry trend, it is evident that AI is significant potential to use for construction progress reporting. AI technology such as machine learning and computer vision can be used to analyze and interpret various data, including image and sensor data, to provide real-time information on construction progress. Another way AI is used in construction progress reporting is through analysis of sensor data. Sensor data can be installed on construction equipment, material, and structure to collect the data for various aspects of construction progress, such as temperature, humidity, and vibration. Machine learning algorithm can be used to analyze this data, provide insights into construction progress, as well as by identifying potential issues that need to be addressed. AI technology have a potential to revolutionize the construction progress reporting by providing real-time data and insights to in the construction progress. By leveraging AI technology such as AI, computer vision, and machine learning, construction companies can improve the efficiency of their operation and reduce the risk of delay and cost overrun. Thank you for being patient with us till the next. Thank you for being patient with us till the end of the session. We are sincerely hope this session was insightful and helped in understanding more about AI in construction industry. Now we are open for question and answer for any question you might have. Okay, we have a question. Can AI be used in facade inspection? Definitely, AI can be used for facade inspection for high-rise building as well. So using drones, the information has been collected using computer vision algorithm. You can detect any flaws in the facade as well. Okay, how is this helpful in maintenance operation? So using sensors, like if you have a centrifugal pump and you have a vibration sensor attached to it, so using whenever there is a spike of acceleration, so using AI, those can be used to predict the downtime of the equipment. This can be help in maintaining of the operation. Mm, okay, these are the questions, and okay. So, coming to end of the webinar. Coming to end of the webinar, Desapex goal is to enable digital technology adoption for target value design, and we continue to provide webinar. Desapex goal is to enable digital technology adoption for target value design, and we continue to provide webinar and written insights on various social media platforms for digital enthusiasts. For more information about our events and posts, please visit us our website, LinkedIn, YouTube, and Medium for Facebook. Thank you for participating, and we will see you in next webinar. Until then, take care.